Hello class, we're looking at section 8.1 today. That's the confidence of the interval of the mean. And so we're going to take a look at an example. There's one formula that we need. In our example, let's say the class average on a project was 50 points. And the standard deviation of those scores was 4. And let's say it was a small class. There was only 16 students. Some more information that they'll give us in the question is they'll ask us what the confidence interval is. And so I'm going to abbreviate that as CI for lack of space here on the screen. You can do the same thing on your homework and projects and exams. So our confidence interval on this question is 95%. Well, from that information, we now need to find the critical value. And so the critical value is marked with Z asterisk. Now, the formula that we're going to be using is X bar, our mean, class average, if you will, and then we're going to need to add or subtract the margin of error. The margin of error would be our critical value times our standard deviation, which would also then be divided by the square root of n. This here is known as our margin of error. All right, let's go back and let's talk about our confidence interval. This is a concept that we're going to want to really understand. And so instead of picking one number, we're picking a beginning number and an ending number. And we're saying that if we were to re-give this project to different classes next year, next semester, 3 years from now, we would expect 95% of those scores to fall within the minimum value and the maximum value. Well, in order for us to find our critical value, we need to determine alpha. And so we've talked a lot about this. So if the probability of rain is 95%, then the probability of no rain would be 5%. That's how you find alpha. It's the complement. But notice there's two sides. There's the left side and the right side. So in order for us to use our table, we're going to have to divide this by 2. Well, it might be easier, since our table goes out to 4 decimal places, to write our alpha to 4 decimal places, and then take your calculator and divide by 2, and half of 500 is 250. And so this value goes into these two areas here, 0.0250, and we can put that in both places. Well, that's the value we're going to get off of our table. So we go and we look at our Z table, we look up 0.0250, we find it's negative 1.96. But the margin of error will always be a positive value. So we get positive 1.96. You might want to go back and stop the video now and look at this, but this is how you set up all the information, and now we're ready to use our formula that we have up here on top. Again, we're looking for the smallest value and the largest value. Here we go. So the class mean was 50, and we're going to have to add or subtract how much? Well, the critical value, 1.96, times the standard deviation, which is 4, over the square root of n, which is 16. And notice the square root of 16 is 4, and 4 over 4 is 1. And 1 times 1.96 would be 1.96. So I did quite a bit of math there, but I think you're familiar with the order of operations. The plus and minus means we're going to do the work twice. We're going to do it once with a subtraction sign, and we're going to do it once with an addition sign. This will help us find our our minimum and our maximum value. And so I'll do the math a little faster, but you have a calculator. You can pause the video here. So when I subtract, I get 48.04. When I add, I get 51.96. And what that's saying is my confidence interval. I am confident that 95% of my samples, not of my students, but of my classes, the class this semester, the class next semester, the class last year, the class 3 years from now, that 95% of my classes, that their project scores would fall between 48.04 and 51.96, as long as we've met all of these conditions over here, that the class average was in fact 50, the standard deviation was 4, and so on and so on. All right, I'll look for your questions on the discussion board. Talk to you soon.